Hello and welcome back to the series in C++. So for today's topic, I will be covering binary trees. So I'm going to start off with a definition of what a binary tree is, and I'm going to show with joint examples how insertion works in binary tree. So a binary tree is a tree data structure in which each parent node can have at most two children. So you cannot have more than two nodes on a single branch. So a binary tree consists of three items. You have a left subtree, a root node, and a right subtree. So here are some attributes of a binary tree before I go on drawing the examples. The left subtree value is always less than the right subtree, and vice versa. The right subtree is always greater than the left subtree. Nodes of the tree are represented in parent-child relationship, so it's like one to many. Each node can have 0 child or a maximum of 2 subnodes on the left and the right side. So say you are given these numbers 4, 7, 1, 5, 9, 3, and 2. The first number or the first piece of data that is going to go inside of the binary tree will be 4. And this node is going to be called root because it's the first node inside of the binary tree. Then you are given the number 7. 7 is greater than 4, so it's going to go on the right side. Then you're given 1. 1 is less than 4, so 1 is going to go on the left. Then you're given 5. 5 is greater than 4, but 5 is less than 7, so 5 is going to go on the left of 7. Then you're given 9. 9 is greater than 4. 9 is also greater than 7, so 9 is going to go on the right of 7. And then you are given 3. 3 is less than 4, so 3 is going to go on the left of 4 because 3 is less than 4. However, 3 is greater than 1, so 3 is going to go on the right of 1. And then you are given 2. 2 is less than 4, however, 2 is greater than 1. 2 is going to go on the right of 1, and 2 is less than 3, so 2 is going to go on the left of 3. Now, when you are coding an insertion function, these nodes will point to null. These are called loose nodes or leaves, and each one of them is going to point to null, so the compiler will know this is the last leaf or branch of the tree. Let's try some more examples. Let's say you are given the numbers 12, 7, 9, 11, 6, 5, 3, and 1. So 12 is going to be the root node. Then 7 is less than 12, so 7 is going to go on the left of 12. Then 9 is less than 12. However, 9 is greater than 7, so 9 is going to go on the right of 7. And then you have 11. 11 is less than 12, greater than 7, greater than 9, so it will go on the right of 9. Then we have 6. 6 is less than 7, so 6 is going to go on the left of 7. And then we have 5. 5 is less than 12, less than 7, less than 6, so it's going to go on the left of 6. Then we have 3. 3 is less than 12, less than 7, less than 6, less than 5, so it's going to go on the left of 5. And then we have 1. 1 is less than 12, less than 7, less than 6, less than 5, less than 3, so it's going to go on the left of 3. And this is our binary tree. So if we take a look at the leaves, we can see that it is in order. Let's go over to the IDE and I will code the insertion function for a binary tree. Inside of my IDE, I have two files. I have a header file that is called int binary tree, and I also have a .cpp file also called int binary tree. So inside of the header file, that's where I'm going to declare the class and define the functions. the first thing I want to do inside of the header file, I'm going to create a class, be called binary tree. And I'm going to close off my class with a semicolon. I'm going to define a structure inside of the class, and I'm going to make the structure public and struct, and I'm going to call the structure tree node. And inside of the structure, I'm going to declare an int variable called value. And I also want a pointer to the left side of the tree and the right side of the tree. And they're going to be of tree node pointer. So the struct pointer. And I'm going to call this variable left. And I also want another tree node pointer. And I'm going to call this variable right. And that's all you need to create the structure. You're going to declare a variable called value, which is going to store the value that is coming inside of the tree. And you also want a pointer to the left side of the tree and a pointer to the right side of the tree. I'm going to create a pointer variable called root, and it's going to be from tree node data type. Root is going to be the first node that goes inside of the tree. And I'm going to create a constructor, and inside of the constructor, I'm going to initialize root to null. Whenever a node goes inside of the tree, or whenever a value goes inside of the tree, you have to point the end to null. So that's how the compiler will know that it's the end. When any other values goes inside of the tree, then it's going to override the null value. I also want to create a destructor. And the destructor is just to clean up when we delete anything from our tree. For this tutorial, I'm going to create an insert function where we can insert the values inside of the tree. I'm going to call this function insert. So it's going to be a void function. And inside of the parameter, I'm going to declare an int variable called num. Inside of the insert function, I'm going to create a couple pointer variables, and they're going to be of data type tree node. And this point, I'm going to call it new node. And this pointer is used to point to the new node that is coming into the tree. The second pointer I'm going to create, I'm going to call this pointer node ptr. And this pointer is used to traverse the binary tree or go through the tree. So I'm going to comment here, pointer to traverse the tree. And this variable is going to be a pointer to the new node. So I'm going to initialize the new node pointer to a new tree node. So I'm going to say new node equals to new tree node. The binary tree is not going to be a fixed size like an array. So the new keyword would make the program dynamic. I want the new node value. So it's going to be new node. And I want to access the value variable. I'm going to initialize the value variable to num. So what this line of code is doing is initializing the value. So remember, new node is a pointer to the structure inside of the class. So once I create a new node from tree node structure, I can have access to the value, the left and the right variable. I want to access the value inside of the tree node structure, and I'm going to initialize this value to the num, or the value that is passed through the parameter of the insert function. And then I want the left node and the right node to equals to null, because when you are getting the values inside of the tree, end of the tree or the end of the leaf nodes should always point to null. So I'm going to do this by saying new node left equals to new node right equals to null. So now I want to do some checking to properly insert the values into the tree. So I'm going to use the if statement. Inside of the if statement, I'm going to say not root. So that means if the tree is empty, then I want to initialize the root node, or I want to initialize root to a new node. So if the tree is empty, then I want to initialize root to a new node. I'm going to add a comment here saying if tree is empty. Else, if the tree is not empty, then take the node pointer and initialize the node pointer to root. So I'm going to use a while loop to insert nodes into the tree. I'm going to say while node pointer not equals to null. So this line of code is saying while the tree is not empty, so while the tree is not empty, insert values into the tree. I'm also going to do another check just so the nodes can be inserted properly or in the proper position. So I'm going to check if the num or the values that is coming in is less than node pointer value. And if it is, then I'm going to do another check. So I'm going to say if node ptr left, then node ptr equals to node ptr left. Let me make this a bit cleaner. And then I'm going to say else, and node ptr left is going to equals to new node. Then I'm going to break out of the loop. I'm going to create another else statement. So I want else if, which is another check, if the number or the value that is coming in is greater than node pointer value. So we're going to check if it's going to go to the right side of the tree this time. So I want my node ptr right, and then I'm going to come out and I want my node pointer going to equals to node pointer right. So I'm setting the node pointer to the right side of the tree. Else I want my node ptr right to equals to the new node, and then I'm going to break out of the loop, and we have to do one more check to make sure that there is no duplicate values inside of the tree, because inside of a binary tree you cannot have duplicates. So we're going to put a simple note to say duplicate value found in the tree. So inside of our program, we're not going to allow duplicates inside of the tree. And then from there, we're going to add our break statement. And that's all for writing the insert function. Now let's create a simple display function to display the values in the tree. So this function is going to be void, and I'm going to call this function display, and inside of the parameter it's going to take a pointer to our structure, and we're going to call this pointer node pointer, and we're going to display the values in the tree in order. So we're going to say if node pointer, so if there is nodes or values or data inside of the tree, we're going to use recursion to display the values inside of the tree. So we're going to call the function again, which is display, and we want to display node pointer, what we created, which is this pointer right here. So it's going to be node pointer, and we want to display the left side of the tree, because the left side is always the lesser side. If you want to display the tree from highest to lowest, then you would call the right side first before the left side, because the right side have the higher values. So let's do a cout statement, and we want the node pointer value And let's call the function again, and this time we want the right side of the tree. And that's everything you need for the header file. So let's go inside of the CPP file and create the main program. I'm going to declare my main, and I'm going to create an object, and I'm going to call the object tree, and then let me create a cout statement just saying inserting nodes, and I'm going to insert some values inside of the tree using the object. So I'm going to say a tree dot, and I want my insert function, and I'm going to copy this line of code several times, and I'm going to paste it in the bottom, and I'm going to insert some values in the tree. So I'm going to put in 7, 9, 2, 6, 3, and 4. So I'm going to create another cout statement for the values. So I'm going to say values in tree. So now I'm going to call the display function inside of my class that I've created in the header file, and I want the display function. And inside of my display function, I want tree dot root. And that is it for the main. So let's build and run the code. The code is starting to build successful. And here is the values inside of the tree. So we have 2, 3, 4, 5, 6. So actually, let me make this a little bit clearer. So I'm going to end a line here, and let's build and run again. Okay, so we have inserted the nodes. When we finish inserting the node, we display the nodes in order. And that's all for this video. Thank you for watching, and see you in the next tutorial.